All right, chapter 2, we're going to be looking at chemistry. All right, then we're going to be looking at different components, carbohydrates, lipids, proteins, organic molecules, and inorganic molecules. Okay, so as we look at it, if you remember from biology 103, they kind of talked about the periodic table, and in the periodic table, they talked about atoms. And in atoms, they talk about protons, neutrons, and electrons. We know that the nucleus of an atom is made up of protons and neutrons, and the orbitals that surround an atom is made up of electrons. We know electrons carry a negative charge, protons carry a positive charge, and neutrons are neutral in weight. Okay? But we know that the mass of an atom is made up of both protons and neutrons. Now the atomic number represents the number of protons in an atom, and the number of protons equals the number of electrons. So we have 92 elements on the periodic table, and they are represented by letters, all right? Oxygen, O, carbon, Ca, hydrogen, H, nitrogen, N, calcium, Ca, then phosphorus, all right? So we're going to be looking at major biological elements and trace elements, all right? So these trace elements here, they make up over 99% of the total body weight. The other ones will represent what we call our minor or trace elements, and they will play a role in the normal physiological function of the body. All right, who knows the definition for matter? Matter. Okay, anything that occupies space and has a weight, okay, or mass. All right. So these are major elements, our trace elements, and our lesser elements. All right. So all of these are important when we look at the chemical makeup of living organisms, all right? So anytime you get lab work done, they're going to look at your hydrogen levels, your calcium, your nitrogen in the form of your kidney function, BUN. They look at your potassium levels, your sodium levels in terms of high blood pressure, the function of the heart. We also look at some of the minor elements and the things that if we don't get naturally being produced, we pick them up in our diet or in the vitamins that we take. But they play a role in the nutritional level of living organisms. All right, so again, organic. Who knows the difference between an organic molecule and an inorganic molecule? An organic molecule and an inorganic molecule. Who knows the difference? Organic molecules have a carbon skeleton, all right, and they consist of living things. Inorganic molecules, they lack a carbon backbone, and they are mainly made up of non-living things, all right. All right, who knows the function of the enzyme or the definition of the enzyme? Enzyme. Anybody? What about a catalyst? Remember what a catalyst is. These are things that speed up chemical reactions, all right? Speed up chemical reactions. All right, electrolytes are things that carry a charge, and we'll look at those and playing a role in terms of the transmission of nerve impulse, like sodium, potassium, calcium. Now we know calcium is important in what? Bone strength, all right? And we get a lot of calcium in what? Things like milk, right? So it's a what? Mineral that's important for the structure of a what? Body. Alright, again when we look at the nucleus of an atom, the center part of an atom is made up of protons and neutrons, alright? And the weight of a proton and a neutron is about 1 atomic mass unit. So they weigh pretty much the what? Same. But electrons, they have no what? Weight. So they don't make up the physical characteristics of an atom. They make up the what? Physical. Or the interactions of it. They determine the characteristics of it. What protons and neutrons makes up the mass of it, they make up how it will react. Right? And remember we said protons are positively charged, neutrons have no charge, and electrons are what? Negatively charged. Okay? Now we will find electrons that are found in the orbit around the nucleus of an atom, whereas protons and neutrons are found where? Inside the nucleus of an atom. Alright? Alright, you hear the term valence electrons? They represent the electrons that are needed in the outermost sheet. So the electrons, they determine the chemical properties of an atom. Now, how many people have heard of ionic bond, covalent bond, and hydrogen bond? All right. What is a covalent bond? A covalent bond. What's the definition of a covalent bond? It is a bond between atoms that share electrons. What's an ionic bond? It is a bond between atoms that transfer electrons. How many people remember oxidation reduction? Oxidation reduction reaction. Anybody? Remember, oxidation is the loss of electrons. Reduction is the gain of electrons. Okay? Yeah, ionic is transfer electrons. So that means one atom has to lose one, the other atom has to what? Gain one. All right? Now remember, all atoms wants to be stable, okay? And they will be stable either by sharing electrons or the transfer of electrons, okay? Question. All right, an atom, they say, is electrically neutral. What makes an atom neutral? What makes an atom be considered electrically neutral? Anybody? What makes an atom neutral? Yeah, exactly. If you got the same number of electrons and the same number of protons, they are neutral, right? Because then we say the atomic number is the number of what? Protons. And then we say the number of protons equals the number of electrons. So if I have 7 protons and 7 electrons, then that means they are what? That's 0, so they are what? Neutral. Alright, so when you look at the Bohr model of an element, remember the center part is the nucleus. And what do we say we find in the nucleus of an atom? What makes up the nucleus? Alright, what do we find in the orbit around the nucleus of an atom? Alright, so if you look at the periodic table, alright, on the periodic table they have letters and numbers, alright? The numbers represent the atomic mass and the atomic number, alright? If you got your book, find the periodic table in your book. Probably in the back in the fifth. And let me see when you find it. So if you look on the periodic table, the top number represents the atomic number. The bottom number represents the atomic mass. Now it may be reversed depending upon how they do the periodic table. But here carbon, the atomic number is 6. The atomic mass is 12. Alright? So by knowing that is, if you got 6, and 6 is the atomic number. What number does that represent for carbon? The number 6. What is that? Atomic number. Remember? The atomic number is the number what? It's the number proton. Alright? So how many protons does carbon have? How many neutrons does carbon have? Huh? You know how you get 6? If you subtract the number of protons from the atomic mass, so what makes up the atomic mass? This number. What makes up that number? So if I got 6 protons, which is the top number, if I subtract that number from that number, how many neutrons do I have? Alright. How many electrons does carbon have? 6. Because we said the number of protons, remember, the atomic number equals the number of protons, and they equal the number of alright. So if I have 6 protons, I have how many electrons? Alright. Now, always remember, the first orbital can hold 2 electrons. The second one, they can hold up to 8 electrons. So if carbon has 6 electrons, how many goes in the first orbit? How many go in the second orbit? All right. What's the valence number for carbon? Yeah, because 4 means it needs 4 more to be what? Stable. All right, nitrogen. What's the atomic number for nitrogen? What's the number of neutrons for nitrogen? All right. How many protons does nitrogen have? How many electrons? How many in the first orbital? How many in the second orbital? What's the valence? 3. All right. Sodium. What's the atomic number for sodium? What's the number of protons for sodium? How many neutrons for sodium? All right. How many electrons for sodium? How many in the first orbital? How many in the second orbital? How many left? It goes in what orbital? The third orbital. What's the valence for sodium? How many does it need to be stable? 7. Or it needs to do what? It needs to gain 7 or lose what? 1. If it loses 1, what type of bond will it form? Ionic. Because ionic bond, by definition, is what? Transfer of electrons. So that means one has to what? Lose an electron, and one has to what? Gain an electron. Question. Make sense, yes or no? Isotopes. Isotopes are different elements that have the same atomic number but different number of neutrons. All right? So they have the same number of protons and electrons, but they have a different number of neutrons. All right? So the physical properties are different, but the chemical properties are going to be what? Similar. Make sense? Yes or no? Huh? Yes. They got the same number of protons, but different number of neutrons. All right? Hydrogen. All right? If you look on the periodic table, normal hydrogen has 1 proton, all right, and the atomic mass is 1. So it has 1 proton, 0 neutrons, and 1 electron. All right? But hydrogen can also have what? H2 and H3. All right? Hydrogen, deuterium, and tritium. All right? So we look at this hydrogen. You got 1 proton, no neutrons, 1 what? Electron. All right? Let's look at this one. We got 1 proton. How many neutrons? How many electrons? All right, so what changed between this one and that one? Neutron. Let's look at tritium. How many protons do we have? How many electrons do we have? How many neutrons? All right, so hydrogen is the same what? Element. But what makes it different is the number of what? All right, but if the number of protons and the number of electrons stay the same, so electrons determine what? The chemical what? Property. Did we change the number of electrons? So it's going to react pretty much to what? Same. Only thing that's different is how much it what? Weight. All right, what's the mass of the first one? What's the mass of hydrogen? Huh? What's the mass? What's the atomic mass? 1. What's the atomic mass for deuterium? What's the mass of tritium? Question. Make sense, yes or no? Isotopes are radioactive isotopes. That means they give off energy. All right? And these isotopes are things that we can use diagnostically to diagnose different types of what? Diseases. So you can use them for what? X-rays from that standpoint. Remember, they have a half-life. That means at a certain period of time, they begin to what? Decay or break down. Now, some of their half-life can be 1 billion years. So it takes them that long to begin to what? Break down. It's almost like an expiration date on meats and milk and things like that. It has a biological what? Half-life. Again, when we look at isotopes, we again look at the amount of energy that they give off. All right. So when we look at X-rays, gamma rays, even radio waves and TV waves, all right, anytime you got a wavelength that's real close together, they are very dangerous for you as compared to those that's further apart. So if you look at a radio wave from a TV, TVs are not what? Harmful to you. But if you get next to the sun rays, what does the ultraviolet sun rays cause? Yeah, skin cancer. What does X-rays cause? It may cause cancer, or it can cause what? Defects. If you're pregnant, don't they always ask you before you get an X-ray? Alright, so the further we go down, the closer these rays what? Get together and go what? After they are what? To you. Alright? That's because when they take an X-ray, with the people keeping the X-ray standing out there with you, they go get behind a dead barrier, right? Alright. And sometimes they'll put one on you, depending upon what part they'll what? Shoot. Alright, so she's the one that kind of coined and came up with what? X-rays. Alright? And what happened to her? She died from radiation poisoning. Alright? At the age of 67. Alright? So a lot of times people who work in radiology, they wear a radiological what? Badge. And it lets them know how much rash you're exposed to over the period of time. And when you get to a certain level, they may remove you and take you out of radiology, put you in a different department, then they'll recycle you back so you're not exposed to too much what? Radiation being what? Given off. Alright, question. Alright. So again, ions. These are charged particles. Alright, remember sodium and chloride. Remember enters the chemical reaction. We said that it is what? Neutral. Alright? Look at sodium. How many protons? How many electrons? This carries what charge? This carries the same number, positive and negative, they equal what? 0. So they are what? Neutral. But let's say sodium and chloride enters into a what? Chemical reaction. All right? Let's look at the valence for sodium. What's the valence number for sodium? 107. What's the valence for chloride? All right? Which one is more practical? For sodium to lose 1 or to gain 7 more electrons? It makes sense to lose 1, because if it gains 7, then it has to interact with that many more what? Atoms to get what? 7 to make it neutral. So if it loses 1, will it be stable? Yeah, because the next orbital has how many? 8. All right, what would make chlorine stable? What's chlorine valence? Huh? Yeah, it needs to gain 1, right? All right. Alright, so an anion is a atom that gains what? An electron. So it carries a what type of charge? Alright, a cation is one that carries what type of charge? So that means it did what? Alright, do we see how that's possible? Yes or no? Alright, remember sodium 11, 23, 11 protons, 12 neutrons, 11 electrons, right? So that is what? Neutral, right? How many protons do we have now for sodium? This one, how many we have? How many in the first orbital? How many in the second orbital? Alright. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. So we got now alright, so we started off with what? 11 protons, right? We lost a what? Electron. The number of protons stayed to what? Same. We lost a what? So now we got what? 10 electrons, all right? A negative 10 from a plus 11 leaves what? Positive 1. So now sodium is what? Is it an anion or a cation? All right, so it lost an electron, so now it carries a positive what? All right, chlorine. All right, we still have 17 protons. How many electrons do we have now? We had 17 and 17, right? But if it gained an electron, how many do we have now? All right, a negative 18 from a plus 17 leaves what? So chlorine, is it a cation or anion? So anytime an atom gains a charge or loses a charge, it is now what? Ionized. So now it went from neutral to having a charge, either a positive charge or a, all right, is this a covalent bond or a ionic bond? All right, give me a definition of covalent. All right, did they share? Okay, so that's a what? Ionic bond. All right, question. Makes sense, yes or no? I don't hear anybody. Alright, so electrolytes are things that ionize in water. Alright? So they can give off an electrical what? Current. Alright? So when we say ionize in water, that means they can what? Break down. So if I put table salt in water, table salt is what? NaCl. Alright? And if I put it in water, remember water can break down into hydrogen plus hydroxide. Alright? And remember opposites do what? So if I break this down with this, that means now sodium wants to combine with what? Huh? The OH. Because it carries positive. OH carries what? Hydrogen wants to bind with what? the chlorine. So now we make sodium hydroxide plus hydrochloric acid, which is a weak acid and a what? Weak base. All right? So ionized means they carry what? Charge. All right? So again, electrolytes, we say, play an important role in what? Chemical reactions. So they allow for what? Nerve impulses to come in to make muscles or glands respond in some form or fashion. Question. All right. So if you look at calcium, all right, then look at sodium and magnesium. All right. What does the 2 plus tell you? Did it gain or lose? It lost 2. What does this tell you? It gained 2. All right? All right. Right? Oxidation means to what? Lose. Reduction means to do what? Gain. All right. All right. The term free radical and antioxidant. Problems to you. They can come. Volatile to your what? Body system. So then they are further to take into account antioxidants. Antioxidants are things like what? Vitamins and nutrients that help us from getting what? Sick. So they help to what? Neutralize free radicals to make them no longer what? Harmful. Like taking vitamin C, alright, or doing vitamin A, alright, or vitamin E, things of that nature. They tell men to eat tomatoes because of the acidity in it cut down on what? Prostate. Alright? Some things that we want to take in to help neutralize free radicals, and these things that trigger destroying our what? Body, cells, and what? Molecules. All right, question. All right, have you said it so far that you don't understand? Yes or no? All right, let's see. This one? Okay. Sodium did we have? Each one lost 1. Potassium lost how many? Potassium lost how many? Chlorine gained how many? Bicarbonate gained how many? Huh? No, it just gained 1. Right. Yeah, but all this makes up of what? Molecule. This is hydrogen phosphate, but it gained how many? 2. Yeah. Right? Makes sense, yes or no? Alright, molecule, compound, molecular formula. A molecule, these are chemical particles composed of what? 2 or more atoms. Right? A compound, they are composed of 2 or more different what? Elements. Molecular formula and structure. Molecular, it tells you how many things you have. Alright? For example, C12. That's the molecular form because it tells me I got what? 6 carbon, 12 hydrogen, 6 oxygen. Structural one tells me how they are what? Arranged. Right? It tells me how I arrange the oxygen and the hydrogen around what? Carbon. This is structure. I got carbon, hydroxide. Molecular is telling me I got what? 3 hydrogen, 2 here, 1 there. So if I add them up, I got what? 3, 4, 5, 6. I got 2 carbons and I got what? 1 oxygen. Alright, so my molecular form is C2H60. Same thing here, right? But what do I have? I got ethanol and I got ethyl ether. Alright? I got 2 different compounds, yes or no? But their molecular weight, is it the same? Huh? No? Huh? How many carbons do I have? I got 2 here and I got what? How many hydrogen? How many oxygen? Alright, so do they weigh the same? Alright? But what makes them different? The way I put these atoms around there gives them 2 distinct what? Chemical properties. I got 2 totally different what? Molecules, 2 totally different what? Compounds. They weigh the same, but they're chemically what? Different. Based on how we what? Arrange the molecule. Makes sense, yes or no? Alright, now let's do this. How do you calculate the weight of an atom or a compound? On the periodic table, remember carbon is 6 and 12, hydrogen is 1 and 0, oxygen is 8 and 16. So by definition, atomic mass equals the number of protons plus neutrons. So if I look here, what's the weight of carbon? 6 or 20. Remember the top number is the atomic number, and the atomic number represents what? Alright. What does the bottom number represent? Remember the atomic number is the number what? Protons, right? And we get the number of protons equal to the number of what? Protons and neutrons. What's the mass of hydrogen? 1. What's the mass of oxygen? let's look at this one. The mass of carbon is what? How many of them do we have? So 2 times 12 is what? Alright, hydrogen is 1. How many of them do we have? Alright, that's what? Oxygen is what? No. It's 16, but how many do we have? 16 plus 24 plus 6 equals what? 10, 16, here my one is 46 what? Grams of C2H6 0. Right? Does this way to yeah, I mean yes. 1 plus 6 plus 4 is what? 6 is what? 4 is what? 16, I write the 6, I carry over 6, 3 plus 1 is what? So this whole situation is what? 1 mole of this it weighs what? 46 grams. So they both weigh the what? 20. The only thing that makes them different is how we arrange the what? Atoms. Question. Glucose is C6H12O6, right? And glucose is considered to be a carbohydrate. That's a what? Sugar. Right? And the backbone of a sugar is 1 carbon to 2 hydrogens to 1 what? Oxygen. Is that the same there? When you look at C6H12O6. So this would be what? 1, 2 to 1 what? Ratio. So if I got 6 carbons, then we know carbon weighs what? Alright, 6 times 12 is what? Hydrogen weighs what? How many of them do we have? Alright, that's 12. Oxygen weighs how much? How many of them do we have? If I add that all up, for every one of these, it weighs what? Alright? What if I had 2 of these? How much would it weigh? 3? Alright. What? Makes sense, yes or no? Alright, chemical bonds. Bonds in between atoms that hold things to what? Yes. So we got ionic bonds, we got covalent bonds, and we have what? Hydrogen bonds. So an ionic bond is a bond between a what? An ion and a cation. Between a positive and a negative what? Atom, charged atom. Alright? So electrons donate from one to the other. The ionic bonds are easily broken down by what? Water. Alright, a covalent bond is a bond that we what? Share electrons. So we can have a single covalent bond, a double covalent bond, and a what? Triple. So a single covalent bond is the sharing of how many pairs of electrons? Single pair. A double covalent bond is the sharing of how many pairs? And a triple is the sharing of how many? Alright, let's look at hydrogen. How many electrons we said should go in the first orbital? 2. Alright, how many does this one have? How many does this one have? Alright, if I share it, how many does this one have now? How many does this one have? Alright, so I make hydrogen what? Gas. Alright? Poison. Alright, let's look at oxygen. We said that oxygen I'm in the first orbital. I'm in the second orbital. I'm in the first orbital. I'm in the first orbital. If we got 8 protons, how many electrons do we have? Oxygen. If I got 8 protons and 16 is the atomic mass, how many protons does oxygen have? I'm in the first orbital. I'm in the second orbital. How many does it need to be stable? Alright. Carbon. Remember? I'm in the first orbital. I'm in the second orbital. Yeah, how many does it need to be stable? 4. Alright. So let's look at oxygen. Alright, this compound is what? Carbon dioxide. What is it? CO2. Think about it. If I draw this one, I got 2 in the middle, and I got what? 2 on the outside, which is what? 4. So this one needs 2. This one needs what? Alright, so if I take 2 from this one and 2 from this one, add it here, I got 1, 2, 3, 4, 5, 6, 7, 8. That's stable, right? 1, 2, 3, 4, 5, 6, 7, 8. This one has 6, but this one can donate what? 2. That one can donate what? So when I look at them, all of them are what? From sharing what? The electrons. So now I'm sharing what? 2 pairs. That is a what? Double what? Covalent bond. Because I'm sharing what? 2 pairs of electrons. Alright, let's take a few minute break. Then we'll talk about polar and... Alright, now let's look at the difference between a polar bond and a non-polar. If you look at the diagram, a non-polar bond is a bond between atoms that share electrons equal. Alright? And a polar one is when they share electrons, but they do not share them what? Equal. So again, with a polar bond, it's the unequal sharing of electrons. They are sharing them, but they are what? Unequal. Now, a polar bond, you can see that they will have a charge affiliated with it. That means one of them will be a positive pole and one is a what? Alright, and what determines it is that the larger the nucleus of that atom, the more time the electrons will spin around it. So if you look at water, water is what? H2O, right? You got two hydrogens to one what? Alright. But the nucleus of oxygen is larger than what? Hydrogen. So the electrons spend more time here than here. They're sharing them, but do they share them in an equal amount of time? No. So that makes this one polar as compared to this one as what? Alright. Alright. So hydrogen bonds is again a weak attraction, alright? So water molecules are attracted to each other by their hydrogen bonds. Hydrogens we're going to find, they are found in what? DNA and protein. Who knows what DNA stands for? Deoxyribose nucleic acid. What's the function of DNA? And where do you find DNA? You find DNA in the nucleus of an atom. They're associated with the chromosomes, and they carry your hereditary information. How many of y'all took biology 103? Been a while. How long? 3 years. You never forget it, like riding a bike. Alright? What's the building blocks of protein? Amino acid. Alright? Huh? Oh, okay. Alright. So they play a role in normal physiology of what? Living things. Alright? Alright, so this is an example of a what? Water molecule, and it is what? Polar. Now when you look at water, water has what? Unique chemical properties. Alright? Water has cohesive and adhesive properties. That means water can cling to itself and it can cling to what? Other objects. Think about it. When you sweat, and sweat is dropping off of you, doesn't it kind of cling to you before it fall off? Or if you cut a faucet off and if it leaks, doesn't it cling to the cylinder? So that allows water to cling to what? Another object, but water can cling to itself to being a what? Liquid what? Alright? And it does that because of what? Its polarity. Alright? Alright, Van der Waals forces is just an attraction, alright? It's based on the density of what? Electrons and the atoms that act with each other. Alright? So we're going to be looking at proteins later on. Alright, mixtures. These are a blend of what? Atoms together, alright? Body fluids can be considered a what? Mixture. Now we are made up of anywhere from 50 to 75% what? Water. Based on our age and our sex and our fat content determines what? Our water what? Consistency. Alright? You can check the sugar of a person's skin. Yeah, and when you do a physical on people, you know, you kind of pull the skin up and look at it and see what? Elasticity. The better it rebounds back, the more hydrated the skin is. And you can do this on your what? Elderly what? Patient. Alright? And you want the skin to stay moist because you don't want it to do what? Dry out. Because when skin dries out, it creates a barrier for things to what? Get in. Alright. Solvency, cohesive, adhesive, thermal stability, and chemical reactivity. So all of these are properties of what? Water. All right. They said water is considered to be a universal solvent. What's the difference between a solvent and a solute? Solvent, solute. Come on. Okay. So what is a solvent? Okay. Okay. So salt would be the solute, which you dissolve in a what? Solvent. So water is a what? Solvency. Alright? Solvent is like water. A solute is what you dissolve in water. Alright, so if you do Kool-Aid, or coffee grounds is the solute. The water is the what? Solvent that comes together to make what? Coffee. Alright, thermal stability is what? When you when you get hot, you sweat, and that helps to do what? Cool you what? Off. And chemical reactivity is that water can participate in a chemical what? Reaction, because it has the ability to what? Dissociate and break down. How many people remember the term hydrophilic and hydrophobic? Hydrophilic and hydrophobic. Phobic means scared or something. So hydrophobic means water hating. Hydrophilic means water loving. Alright? So water is considered to be a universal solvent because majority of things can dissolve in what? And we are 50 to 75% water because when we take medicine, when we eat food, it what? It dissolves and what? Breaks down. Makes sense? Yes or no? Alright, metabolism. Who can give me a definition for metabolism? Huh? Alright, it's your metabolism is your metabolic rate. How things are chemically and physically what? Broken down and built up. So anytime you go through metabolism, your body makes what? Waste. Right? And metabolism has two parts. Catabolism and anabolism. We talked about this last Tuesday. What is the definition for anabolic? Anabolic. That's when you take two smaller things and make them into something what? Larger. So I asked you what was the building blocks of protein. You said, so if I combine amino acids together, they make a what? Alright, so that's anabolism. If I take a protein and break it down into amino acids, that is called what? Catabolism. So anabolism and catabolism are the two components that make up what? Metabolism. And metabolism depends upon things being able to be broken down in water. Alright? So remember when we said sodium chloride mixed into what? Water. Na binds with OH to make sodium hydroxide. Hydrogen combines with chloride to make what? Hydrochloric acid, so it makes a weak acid and a weak base. Alright. Adhesive and what? Adhesive. One substance to cling to another. So it can adhere to large membranes, reducing friction. Cohesive, they can cling to what? So water can cling to itself. It can cling to what? Other surface. And surface tension is a film that covers things to allow it to what? Work. So we said ionization. So water can ionize into what? Hydrogen and hydroxide. OH means what? Hydroxyl. Alright? So hydrolysis means to do what? Add water. Dehydration synthesis means to what? To remove water. Right? If you're dehydrated, that means you're doing what? you thirsty. You have lost what? Water. So if I drink the water and I hydrate myself, that's what? Hydrolysis. Alright. Alright, we said thermal what? Stability. Alright. So you can raise the temperature by 1 gram of any substance by 1 degree what? Celsius. Alright, so hydrogen bonds can inhibit a rise in temperature by inhibiting molecular what? Motion. I remember last time, if you put water on a hot stove and heat it up, does the molecular motion increase or decrease? Now that means you can convert water from a liquid to a what? Alright, what if we put it in the freezer? What happens? Alright, so if put it in the freezer and we inhibit the molecules from interacting, then we resist from changing in what? An increase in what? Temperature. Alright, so solution can be in a you can intermix things, a mixture. Alright, so you can make a solution, a colloid, and a suspension. Alright, so then we're going to mix different things. Alright, so when you look at a solution, these are particles that are less than a nanometer in size, and they really do not scatter a lot of light. And what that means is, if you look at the first test tube, it tends to be more what? Transparent. Light tends to can what? Pass through. Right. Look at colloid. Do you think light can pass through that? It's milk, right? So if you try to shine light through it, it's gonna what? Scatter the light. So a colloid is much what? Larger, right? They tend to do not really pass through a membrane, so they need what? Help to pass through it. Alright, suspension is even what? Large. Alright, it's cloudy and what? Opaque. So if you let it stand, it can what? Separate like blood. When you take blood and you centrifuge it, it separates out to the heavy elements going to the bottom, and the lighter elements staying at the what? Top. Alright, so table 2.4 just shows you mixtures and their diameter and size, and whether or not they can easily go through a membrane or they need what? Help. Alright, when we measure concentration, alright, weight per volume. So if you look at IV, normal saline, there's about 8.5 grams of sodium what? Chloride per liter. How much is a liter? 1,000 what? Milliliters. Alright? So if I take dextrose, that's sugar water. Normally before a diabetic goes to surgery, they tend not to give them their insulin or their blood sugar medicine because they may be to follow. That means you're not the first one scheduled, and they never want your blood sugar to drop too low. They'd rather for you to have a high blood sugar level than a what? Low. They give you sugar water. So that means you got 5%. So for every 100 that gives me what? 5%. So if I look at ethanol, if it's 70%, that means I got 70% of that mixing in what? Alright, molarity, that's the number of moles. Glucose up there that weighed 180 grams. Who remembers the molecular C6? Every 1 mole of glucose, it weighed how much? So look at the diagram first. It says the number of molecules are equal but the weight is what? Equal. Alright? Look at glucose and look at what? Alright, sucrose is what we call a disaccharide. And glucose is a what? Mono. Mono means what? Di means what? So sucrose weighs how many grams? If it's a disaccharide. Yeah. So one weighs how many grams? Glucose weighs how much? Alright, so if I put two of them together, they okay. Alright. So look at the beaker on this side. Alright? And look at this one. Do I have more molecules in this one or more in this one? Which one has the most molecules? Glucose or sucrose? This way is what? If I have nitrogen in here, then here, I need 2 times the number here equal the number what? Make sense? So my percent, the number of molecules, that means I got more of these than I have what? Here, but the weight is the what? Same. Alright? So if I got they weigh what? Alright. Alright, molar. That's the number of moles are equal. Will the weight equal? Yeah, because if I got 10 of these and 10 of these, 10 of these weigh what? 360, right? 10 of these weigh how much? So I can have the same number, but this weighs twice as much. Because that's twice as what? Heavy. Alright? Makes sense, yes or no? Calcium has a plus what? That's how many I'm looking at. I'm looking at the what? Base. So calcium lost how many electrons? Alright. Sodium lost how many? That's how nearly what? Okay. How many people remember acid and base? How many people remember PhD. PhD goes from what? Alright. So anything below what? Anything above 7 is what? Alright. Anything at 7 is what? Alright. So if it's neutral, that means the number of hydrogen ions equal the number of what? Hydroxide. If it's negative, that means the number of hydrogen is greater than the number of what? Hydroxide. If it's base, that means the number of hydroxide is greater than the number of what? Hydrogen. So the more hydrogen you have, the more what? Acid a solution what? The more pH it has, or what? to 3. Yeah. Alright? So every time you do a 1, you increase what? 10 times the acidity. If I go up 2, that's 100 times more what? If I go up 3, 1,000 times acidity. So the normal pH of blood is 7.35 to 7.45. Right? So what does it mean? Who remembers what's wrong? Because it tries to bring the pH back in what? Balance. Right? So it resists a what? Change in the pH. Alright, so these are the different pHs of different what? Compounds. So water is pretty much what? Neutral. Alright, energy, the ability to do what? Kinetic energy is energy in what? Motion. Like chemical energy is that we find between what? Bonds. Right? When we break the chemical bonds, we do what? Release energy. If you put chemical energy in a bond to hold something together, that energy is stored in the bonds that you what? Release. So free energy is potential energy in a system that has the ability to do work once you do what? Release. Question. Alright, we talked about kinetic energy, that's energy in what? Motion. Alright, electromagnetic energy, that's energy that gives off what? Photons in the form of what? Electrons. Alright, when we look at reaction, alright, you got decomposition, synthesis, and exchange. Alright, and normal reactions normally go from the left side to the left side. They are what? Reactant. The right side is your what? Product. Now, if the arrow goes in both directions, that means the reaction is what? Reversible. So that means we can go from left to right and then from right back to what? But if it only goes in one direction, that means it only goes from what? Left to right. Alright. Decomposition. What? Alright. So decomposition, what would be another thing for decomposition when we look at metabolism? Metabolism. You take a large molecule and break it down into what? A synthesis is when you do what? ATP. So what type of reaction is that? Metabolism. Anabolic. Definition of that. What is it? What's going on? I got 18 plus CD. Then I have to do what? I combined them, I broke them down, and they what? Reform versus a combination of what? Synthesis and what? Decomposition, so things to do what? Exchange. Alright, question. We talked about reversible, right? Alright. What is equilibrium? Yeah, when the reactants and the products are what? Equal in concentration. Alright? Yeah, the ratio of products and reactants is what? Stable. Enzymes, what do we say enzymes do? So remember, they speed up chemical reactions. Alright? Alright, catabolism, energy what? So you broke it down. Hexagon, anabolism, build something up. That means I'm putting energy what? Heat. That's endogun. Endogun is added energy to stabilize. Hexagon is what? Releasing energy. So catabolism and anabolism is the sum of what goes on in what? Metabolism. Or oxidation what? Reduction. Right? Lose energy of what? Gaining. So if something is oxidized, it loses something. So that's carried out by, so whatever accepted it is the oxidizing agent. When it's reduced, that means it accepted something. But whatever donated it is the what? Reducing agent. So when we look at sodium and chloride, sodium would be what? The reducing agent or the oxidizing agent? Sodium and chloride. Remember, sodium gave up the electron, right? It's the reducing agent. What gave the electron? It's the oxidizer. But sodium was what? Oxidized. Chlorine was what? Reduced. But sodium is the reducing agent because it donated. Chlorine is the oxidizing agent because it what? Accepted. Question. Alright. Remember, sodium gave up an electron, right? So it was oxidized. Chlorine, it was, but the fact that it accepted it, it made it the what? Oxidizing agent. Alright, so this is just a table 2.5 that kind of goes through that. Alright. Inorganic. Alright, organic chemistry. Remember we said organic molecules contain a carbon backbone. So we got 4 categories of organic molecules: carbohydrates, lipids, proteins, and nucleic acids. Okay? Alright, carbon has a valence of 2 electrons in the first orbital and 4 in the second. Right? So it needs 4 more to be what? Stable. So carbon can form a covalent bond with hydrogen, oxygen, nitrogen, and what? Sulfur. Now when they talk about a functional group, these are groups that bind to things that give them their unique chemical characteristics, okay? So look at the figure. You see hydroxyl, you see methyl, CH3, carboxyl, C double bond O, amino, NH2, and phosphate, all right? So again, when we add these molecules to something, which are considered to be the what? Functional group. So nucleic acids are things like DNA, RNA, and ATP. Who knows what ATP stands for? ATP. Adenosine triphosphate. What's the function of ATP? It's energy. That's what our body makes in the form of energy for us to carry out our what? Activities. Okay? Alright, macro means what? A large molecule. Polymers is when we take several of these molecules and put together. So monomer is like a what? Single one. A polymer is what? Many of them what? Alright. Polymerization is how we join them what? Together. Alright? Alright. What did we say dehydration synthesis was? Alright? And synthesis means to do what? Oh, okay. So dehydration synthesis is when we combine and make a smaller molecule into a larger molecule by removing a what? Water molecule. Alright, what about hydrolysis? What is that? By doing what? Yeah, so if we add water back to something, we can break it back what? Down, right. Into two what? Smaller molecules. Alright, look at this diagram. Look at monomer 1 and monomer 2. Alright. If I remove a hydrogen from monomer 1 and a hydroxyl group from monomer 2, we make what? H2O and a dimer. That means when we remove hydrogen and hydroxide, we make a bond called a glycosidic what? Bond. Alright? So that's there. So I took two monomers, combined them together to make a what? Di. By doing what? Removing water. So I took two smaller molecules, made them into a larger molecule by removing water. Alright? Hydrolysis is what? Splitting. So if I add water back to this, I add a hydrogen back to what? One of them, a hydroxyl group back to the other one, and I break a larger molecule back down into what? Individual molecules. That's what they call by hydrolysis, splitting. So dehydration synthesis is combining them by removing water. Hydrolysis is splitting them by what? Adding water. All right, question. All right. Hydrophilic we say is what? Okay, hydrophobic is what? Alright, so ONC or saccharide, these are what we call a suffix or a root word that means what? Sweet. Alright? And remember the backbone of carbohydrate is 1 to 2 to 1. 1 carbon to 2 hydrogens to 1 what? Oxygen. Or C6H12O6 is in a 1 to 2 to 1 what? Ratio. Alright. Alright, so we got 3 monosaccharides. Glucose, galactose, and fructose. Okay? They all have the same what? Molecular formula, but they got different what? Structural
formulas. If you look at all of them, each one is C6H12O6. But look how they are arranged. That makes all of them what? Different. Okay? Makes sense? Yes or no? Alright. Alright, a disaccharide, what is that? Alright, so again we got 3 disaccharides. Sucrose, lactose, and maltose. Alright, so sucrose is table sugar. Alright, and what 2 things make table sugar? Okay then. Milk sugar is lactose. Alright, what makes lactose? Alright, maltose is grain sugar. What makes maltose? Alright, so what type of reaction do I put these two to get a disaccharide? What type of reaction? Thank you so much. All right. Huh? You will. All right. All right. Oligosaccharide and polysaccharides are what? Sugars. Oligo means it has at least what? 10 or less. Poly means you got 50 or more what? Held together. So a polysaccharide is a very large what? Sugar. You got 3 types: glycogen, starch, and cellulose. Right. Glycogen we store it where? In our liver cells, our muscle cells, brain, your uterus, and your what? Vagina. Starch is in plants. All right. It can be digested by humans. Cellulose is found in plants. All right. It is indigestible to us, but it gives us what? Roughage and fiber. So like salads, it helps to pass through our colon to help us what? We can't really break it down, but cows can what? Break it down. Okay? So glycogen, starch, and cellulose are what? Polysaccharides. So these are long chains of monosaccharides. Question. So when we eat meals that are high in sugars, we take insulin. Our body produces insulin, and it stores the glucose in the form of what? Glycogen in these different parts of our what? Body. So in times of starvation, our body can break glycogen down back into what? Glucose. Now when you have diabetics that eat milk, bread, grits, rice, all of these are rich in what? Starches. And you break starch down into what? And sugar raises your blood what? Alright, so you ain't got to eat nothing sweet. If you think with carbohydrates, that runs your blood sugar up. That's why they tell diabetics to count your what? Carbs. Because they're nothing but what? Alright. Question. Alright. Huh? Nope. Alright. Glycolipids, glycoproteins, and proteoglycans. Alright. They mention the terms a conjugated molecule or a moiety. M-O-I-E-T-Y. That is when we take 2 different molecules and combine them together. Glyco means what? Sugar. Lipid is a what? Fat. So glycolipid is a sugar and a fat together. Yeah. Glycoprotein is a sugar and a what? Protein. Proteoglycans is a carbohydrate and what? A protein. Alright? So these are things that we find on our cell membranes, part of our respiratory tract, our digestive tract, and also they can lubricate our what? Joints and cartilage. All right? All right. So table 2.6, it breaks them down, and it's a quick reference to what they do. Okay? All right, lipids are what? Fats. You got fatty acids, triglycerides, phospholipids, eicosanoids, and steroids. These are 5 types of lipids that we find in human bodies, okay? So they have more calories than carbohydrates per gram, all right? So some things say they are low what? In fat content, all right? All right, they mention the terms saturated fats and unsaturated fats. Which ones are healthier for you, a saturated fat or a unsaturated fat? All right. Saturated fats, they are solid at room temperature. All right. How many people gone in the store and saw Crisco? All right. Crisco is a liquid or in a can, which is a thick white solid mass of stuff. All right. The reason why they call them saturated fats, look at all the carbons. Do you see any of the carbons free? They're all abound with what? Hydrogen. All right. They're liquid at what? When you heat them up, but they're solid at what? Room temperature. How many people ever cook with Crisco? All right. So when you cook with it and you let the skillet cool down, what it looks like? So what do you think it do in your arteries? After it cool back down. So how do you get hard in other arteries and arteriosclerotic disease? It makes the food taste better, but is it healthy for you? All right. So again, saturated, they have a lot of what? Hydrogen. All right. So they are unhealthy for you. All right, a unsaturated fat, all right, they don't show an example, but a unsaturated fat, it will have double bonds between it. So they are liquid at room temperature. Peanut oil, all right, canola oil, vegetable oil, corn oil, peanut oil. They are all healthy for you because they are what? Liquid at what? Room temperature. Alright, so again, triglycerides are neutral fats. You got 3 fatty acids and a glycerol. They are made by what? Dehydration. That means you remove water to combine it. They are broken down by adding water. Triglycerides, again, liquid, oil, polyunsaturated, from plants, healthy for you. When they're called fat, they're saturated. These are from what? Animal. There you go. All right. That's good for you. Yeah. But these animal fats, bad for you. Crisco, if it's saturated, it's not good for you. If it's unsaturated, it's good for you. Look at it. Right. So fats do what? Inflammation. Alright? They help you what? Store energy. They keep you what? Warm. Alright? Alright, trans fat and cis fatty acids. Alright? Trans, you got 2 covalent single bonds. They in opposite, alright, trans across each other. On each side, double bond.
rich fatty acid. Lipids, these are what reside in what? These are hormone-like chemicals like prostaglandins. They can cause inflammation, they can cause blood clotting, and they affect the diameter of blood vessels. Okay? And stimulants, again, cholesterol. These are things that can also be what? Harmful to you if in what? Large quantity. Can also make you retain. Yes. Alright. Alright. Progesterone and estrogen. And birth control pill can be based or what? Okay. Depo-provera injection women can take every 3 months and juicy white fluid that helps you get pregnant. It's a steroid. Can make you gain weight. Steroids and steroids in. Alright? These things help you to take it characteristics. Muscle mass, the boy, basic, women, get up things like that. HDL. HDL is high density liver. They are good for you. LDL, they high lipid to protein ratio. This is what? Vascular disease. So your LDL is your bad protein, HDL is your good. So table 2.7 breaks it down. Alright, the amino acids, that's the protein, amino acids. Amino acids have an amino and a carboxyl group. We have known amino acids, alright? We can rearrange in 6 to 14 combinations. Amino acids we look at in terms of genetic code, alright? The DNA, deoxyribonucleic acid, hereditary information, what RNA stands for? Ribonucleic acid. Their role in making protein. Okay? Alright. 29 amino acids. What makes them different? Look at this man, right? All of them. What makes them different? This group gives us our 20 amino acids based on their that's bound at what? Peptide is the bond that holds protein can be what? Stiff. Just like and we make proteins by what reaction? There you go. People heard of depolymerization. That when you put some much heat or add an acid, people have cooked their egg. The egg is a protein. When you put it in heat, what happens? Now, yolk, albumin change what? Taste and what? Yeah. So it means taste of the alter based on what? Heat. So protein be what?
much heat on you happen to you. So something. Right? So that means we're not function what? Heat before we chew in too much heat for acid. Makes sense? Like protein, primary, secondary, right? Everything. Linear sequence, like a line. Secondary can be put apple. Here means it's fold. And quarter means it's like it even move. Alright? Hemoglobin, where we find hemoglobin at? And you see it. Alright, hemoglobin is red blood. Red blood cells made up of what? Heme, which is iron and protein. Heme, iron, protein. Red blood can have what? So they find oxygen and dioxide, but they're put in like a core structure to make it proteins. Proteins are all introduced throughout our cell frame. They allow to come in and go. Protein also help to shape and structure, like protein, nail. Hard or they what? What's it? Two things. Heme is what? Okay. So anemic, that means you're over so what? That means they make red cells have what? Iron. Okay? So, in terms of things that have membrane, and they all act as a catalyst, speed, chemical, skeletal contraction. So for you to move, that means two proteins, what? Act. Alright. The definition act. People heard of fight or flight. People heard I mean, autoimmune diseases. Autoimmune disease. Say autoimmune disease. Alright? Rheumatoid arthritis is autoimmune disease. Autoimmune disease, your body begins to what? Turn on its. So that means the body does not recognize what? And more. So self and self. The energy that did you when you were is the input as far as you get sick. Then foreign. It a trans foreign. You can what? Reject it. Because it's not so mission and protect its system. That's protein. Your white cells. Antibodies. Alright? How things to each other. Alright? How does protein protect you? How do you get the head? How many to take the head? The one fertilized one sperm that is with it. It's the shape of the sperm. Fertile means you got the fertile.
whatever it is. That means when positive got more than said. And a woman had a baby and a birthday to say same time or same night. No, is one that's gentle. He said 3 times. But when they have these quadruplets and 8 tough, that means first field. Bunch of being fertile at different spots. But on sperm fertilized then what? I said they can't put just all that in. What you mean? Alright, so they what? Other. Alright, time we speed up action. Enzymes have called a site. That means specific in what? Substrate. Anybody toasting? Alright, lactose. Enzyme taste. Alright, so the thing that will lactose is the enzyme lactase. When you buy taste, there is already put down, divided up to. The enzyme is specific. A what? Substance. Times can what? Usable. For the active site on enzyme specific at what? Substrate. Logic mechanism. Right. What is the station of active energy? Remember that. Body. Yeah. Presence of fluid. You more energy as your word. Talk about lack of difference and the right. take sometimes look in it when they pick election, gonna be to N H it carries to the what might have what it might just the what power of the said H and we bring Peruvian to go create the PT and to when we go to we're gonna be looking abs 4 you're gonna be looking organism we find what animal and their gonna be looking just processes. We're gonna be looking at different cells of the looking at over testing, looking at the sperm cells spermatogenesis also. The ends of metabolic pathway unique signs run. So from making be what? Now, I take for what? Will I what? Oh. In a way, first, what? So I will be I'm trying to okay? I just think they look beside me. These couple pop. That's what? Energy. That's energy. What? For what? Occupation. Hey,